Okay guys, starting with the next question of today, which is majority element 2. Obviously the question is related to the previous question, majority element 1. Given an integer array of size n, find all elements that appear more than floor of n by 3 times. So if an array is of size 3, then n by 3 is basically 1. So the element, majority element is the element or elements that appear more than n by 3 times. That is you have to be present for 2 times at least in order to be considered as the majority element when the size is 3. Similarly, if I take more examples, suppose 3, 2, 1, 2, 2, 3, 1, suppose this. Okay, so what is the size of the array? 0, 1, 2, 3, 4, 5 and 6. So the array size is 7. The indexes run from 0 to 6. So 7 by 3, basically it is 2 point something. I can say this is 2 if I take only the integer value. Now the elements, if a particular element is present more than 2 times, then only that will be considered as the majority element. So if a number is present at least 3 times, then only it is considered as majority element. Now over here, as you can see, 2 is present for 3 times, no other element is present for 3 times, but maybe instead of this 1 over here, maybe a 3 was present. If a 3 was present over here, then both 2 and 3 would have been present for 3 more than 2 times, and thus both of these would have been the majority element. Now if you look at carefully, in an array of any size, there can be a maximum of 2 majority elements only. Why? Because for one element to be a majority element, it must be present for more than 1/3 of the times, which is more than 33% it should be present, or I can say 34% it is present for 34%. So if another number is also majority element, that should also be present for more than 33%. Just let us consider as 34%. So if two elements are taking up 68%, then there is no space for the rest 33.01% even, right? So the majority element can be 0, there can be array where there is no majority element, or one majority element can be there, or two majority elements can be there at max. Now obviously you need to return a list which contains all the majority elements. That is the question, that is what the question is demanding. Now the most common approach is, guys, obviously to use a hash map, frequency hash map, where we keep the number and their frequency. For example, over here if we just iterate, 3 is present one time, after that we come over here, 2 is present for the first time, then 1 is also present for the first time. Also, while incrementing this particular frequency, we can check if frequency is greater than my n by 3 or not. If that is the case, I can directly add it to our created list. Let's continue. See, now again a 2 comes, so the frequency of 2 becomes 2. Then again a 2 comes. This time, as soon as we see that the frequency is more than n by 3, we put that particular element inside our array list. After that a 3 comes, the frequency of 3 becomes 2. Then again a 3 comes, so the frequency becomes 3. Now mind it that if there is another 3 and we increase the frequency, we won't consider that 3 again. As soon as it hits the threshold mark, which is just above n by 3, then only we put that particular key inside our answer. If it is present for more times, we won't put it again, right? So that is the idea. In one complete iteration we can build this hash map, and again we can actually iterate through the hash map and find out which are the elements that has a frequency of more than n by 3 times, or while creating the hash map only we can put a check. So if I want to discuss the time complexity and space complexity of this approach, obviously the time complexity is order of n. In one complete iteration we are doing it, and the space complexity is also order of n, because in the worst case scenario all the numbers would be different in the array, and for that, for each number one key value pair will be created in this hash map, and thus the space complexity at worst case will go to order of n. I hope this is clear. Now this is also very optimal, but there is another optimal approach where there is basically we are not using any extra space in that approach, right? We are doing it in order of n time and order of 1 space. This is our target, right? What we can do is, I would highly recommend anyone to everyone to like complete the majority element 1 wala video and after that come to this, because the intuition is going to remain the same. In majority element 1 we saw that a element will be a majority element if it is present more than half the length, right? Here it is n by 3. Here maximum one element would have been the majority element, and here maximum of 2 elements can be a majority element. Over here we deployed only one value for candidate, one value for choosing the candidate which can be the majority element, and another variable maintain the count of that particular variable. Over here we will switch things up a little bit. See, this is not a very intuitive approach that you will be coming across in everyday solution. This is one of a kind, so you should take it in that way, right? The intuition is matching to this n by 2 approach, where here there would have been maximum of one majority element, so we had one candidate and one count. Here we will be having two things, candidate 1 for which count 1 will be there, and we will also need to take candidate 2. There can be two candidates, right? Candidate 2 and count 2. And at the end of the iteration, we will be, as soon as we get if suppose we assign some number with candidate 1 and another number with candidate 2. Now if candidate 1 number is repeated, then count 1 is incremented. If candidate 2 number is matched with the current element, then we increment count 2. Now the point is, if an element, we come across an element, if the current element of the array is not equal to any one of these, then we will be subtracting from both of them. Why? Because we are not really interested in finding out that how many times the majority element is present. We can do that later as well, but our candidate 1 and candidate 2 will be consisting of element that is present most of the times. Now again we need to check, this point is very important guys. After the end of the iteration, candidate 1 and candidate 2 will hold two elements, one each. Now these elements might not be the majority element. These elements for sure are present for most of the time in the given array, but it is not, we are not sure that it is present for more than n by 3 times. That we need to do after we have one element in each one of this. We need to iterate once again and check how many times candidate 1 is present and for how many times candidate 2 is present. That will give us the final result, which one should be included among these two. So the first approach is pretty simple, hash map approach. I am not coding this up. I will show you the code directly over here, and meanwhile I'll be in the middle, I'll be showing you what are few of the mistakes that you should not make, right? So first I'll make an answer list. Obviously list is a interface, you cannot instantiate that. You need to take any implementing class of that, which is an array list, for example, array list of integer, right? Now after that, what you can do is, what I'm saying is, you need to make 4 variables. First you need to do int n equals to nums.length, finding out the length of the array. After that, what do? You create 4 variables. Suppose candidate, let me write the full names only. Candidate 1, I'm assigning it with a value, which value will never be a possible value of the array, which is maybe integer.max value or integer.min value, anything. Integer.min value, for example, right? After that, we'll also have a count 1 for how many times the candidate 1 is present. If candidate 1 is present for more times, the value will be incremented such that other elements won't be able to decrement that value, right? And once any count becomes 0, then only we update it to the new, we update the candidate to a new element, right? So initially it will be 0. After that, I'll need to make another set, candidate 2, which will be again equivalent to integer.min value, and int count 2, which will be initialized with 0, right? After that, we will be doing the normal iteration from I equals to 0 to I less than n, right? After that, what we need to do, we need to check if the current element, if the will be iterating nums, right? So if the current element is equal to the candidate 1, or if it is equal to candidate 2, we should increment its count, right? So I'll do that. If my nums of I is equals to my candidate 1, then what I should do is count 1 plus plus. Else if my nums of I is equal to my candidate 2, then I will increment count 2, right? After that there can be a possibility that this count 1 or count 2 is 0, which is the case for the initial case also. Initially count 1 and count 2 both will be 0, so we need to assign them with a candidate. So I'll check that if at any point my count 1 becomes 0, then I should change the candidate. My candidate 1 should be equals to nums of I, right, the current element, and also I should increment the value of count 1, like it was 0, that's why we came inside, now we are setting it to 1, right? Also guys, similarly if the value of count 2 is equals to 0, then candidate 2 must be equals to the current element and count 2 will be 1, right? Also there can be a case guys where we come across a number which is not equal to the number that was assigned to candidate 1 and candidate 2. So in that case, else we will be decrementing from both the elements. It's kind of a thing that there is an element that is not supporting candidate 1 and candidate 2. So count 1 should also be decremented and count 2 should also be decremented, right? And at the end of it, as I have told you guys, we are not sure that whatever is present in candidate 1 and candidate 2 need not to be the main element, like need not to be the majority element. Maybe they are present for most of the time, but yet it is not present for more than n by 3 times. So what can we do it? We set, after we come out of this for loop, okay, we have the majority elements present and like the elements that are present for most number of times in candidate 1 and candidate 2 in these two variables, but we need to check their counts. So I'll set this count 1 to 0 as well as I'll set the count 2 to 0. Then what I'll do is I'll iterate through the array once again, int I equals to 0, I less than n, I plus plus. Then I'll try to find out if my current element is equal to my candidate 1, right? That is what I took, yes, candidate 1. Then what I am doing is count 1 plus plus I am doing, and also if my nums of I is equal to candidate 2, then what I am doing is I am incrementing count 2, right? Now after I have counted the number of times candidate 1 is present and the number of time candidate 2 is present, what I can do is have I made the array list? Yes, I have made the array list. Okay, so there should be one condition where there is only one element. In that case, obviously the size of the array is 1 and it is present for more than 1 by 3 times, which is 1 by 3 is basically 0 and greater than it is 1 time, so that will be the majority element. So in that case, that is our edge case. If my n, okay, I have not declared n, come in the next line. If my n is equals to 0, right, then what we can do is we can basically add answer dot add the first element terms of 0 and I can return this answer, right? Otherwise if we are coming over here, then we need to check if my count 1 is greater than n by 3. That is the case, I should add this to my answer list, answer dot add candidate 1. And similarly if count 2 is also greater than n by 3, then we should add that as well, answer dot add candidate 2, right? So either both of them will be added or one of them will be added or none of them will be added. Whatever it is, after these two checks I will be returning whatever will be inside my answer array, answer list, right? Just run this. So there are certain things that you should take care. This is a little bit on the tougher side, I won't lie, but the thing is guys, make did not beat 100%. Why? Okay, so maybe this thing is not necessary, maybe this thing will be handled generically. So if you just remove this, it will be beating 100%, near about 100%. See, 99.47, cool. So you even if you don't handle the case of a single integer, this is generic. One thing remember guys, that if you place these two conditions, count 1 equals to 0 and count 2 equals to 0 above these two conditions, then you should always make sure that count 1, if it is 0, it should not be assigned with an element that is already been present as candidate 2. Candidate 1 should not be assigned with a number that is already present in candidate 2, and also vice versa. If candidate 1 is having a particular number and candidate 2 at some point goes 0, then candidate 2 should not be assigned with the value that is getting holded in candidate 1, and similarly vice versa, both the things. So that's why if you put these two conditions above, you need to also check one more thing, which is you have to check that candidate 2 is not equals to nums of I. That is what you need to check. I hope this is also clear. Otherwise, at certain cases you can run the case, it will be getting stuck at a particular case. You can view that case and you will find the things out. And also I will be what is the how much is the recording? Okay, I cannot see, but okay, let me also do a, if it is clear, you can close the video. Otherwise I'll just give you a, like, I'll do a dry run of one of the examples and show you how exactly things are working. Okay, so maybe I'm taking 1 1 2 3 4 8, maybe then some 4 4 4 1 1. So what is the size of the array? 3 4 5 6 7 8 9 10 11. 11 by 3 gives me 3 point something, which is 3. So if an element is present for 4 times, then only it is a majority element. So if we can see over here, 1 is present for 4 times and also 4 is present for 4 times. Now let us check what is happening. First, our there are 4 variables: candidate 1, count 1, candidate 2, count 2, right? After that, initially this is minus infinity, this is also minus infinity, and the count is 0. Okay, now first I come over here, first is this 1, then what do I check? First I check if this 1 is equals to this candidate 1. No, it is not equal. Then we check if this 1 is equal to candidate 2. That is also not equal. Then the third condition that we checked was if count 1 was 0. Yes, count 1 is 0. Then what do? We set candidate 1 to this current element, which is 1, and set the count to 1 as well. Then next iteration, we again come across a 1. First we check if this 1 is equals to the first candidate. Yes, they are same. So I just increment the count. After that I come to 2. This 2, now I compare this 2 with 1, candidate 1, they are not the same. So I compare this with candidate 2, they are again not the same. So the next condition that should be checked is count 1 0? No, count 1 is not 0. Then we check is count 2 0? Yes, count 2 is 0. So if count 2 is 0, set candidate 2 to the current element, which is 2, and we'll also change the count to 1. After that we come across a 3. Now guys, check this. 3 is not equals to candidate 1, it is also not equals to candidate 2. Then it will check is count 1 0? No, it is not 0. Is count 2 0? No, it is also not 0. Then it will go to the else part, and what it will do is decrement both of these. This will become 1, this will become 0. Cool. We'll move to the next iteration. 4 is there. So 4, what it does is, 4 will check candidate 1. Is it equal to candidate 1? No. Is it equal to candidate 2? No. Is count 1 0? No, count 1 is also not 0. Is count 2 0? Yes, it is 0. So what you will do? You will make this 4 and you will reset the count to 1. That is what we do. After that we come to 8. 8 is not equal to candidate 1. So, and it is also not equal to candidate 2. Then count 1 and count 2, any of these two are also not 0. So we will be decrementing both. So this will also become 0, this will also become 0, right? After we have 8. Then we come to 4. Now you check, is 4 equals to candidate 1? The answer is no. Then is 4 equals to candidate 2? Yes. So luckily the value will be incremented to 1. We will not be checking the else if wala condition where it is saying that count 1 is 0 and count 2 is 0. Before that only, in the second second condition only, if then else if only, the candidate 2 will match to the current element. That's where we will be incrementing its count. So it will be 1. We'll come to the next iteration. This element is not this element over here is not equals to candidate 1, it is equal to candidate 2. So we'll increment its count. Again there is this 4, it will increment the count of candidate 2. Then we come across a 1. Is it equal to candidate 1? Yes. It has increased. Again 1 came, it has increased. So you see 4 is present for 3 times but the count is only 3. 1 is present for 4 times but the count is 2. That is what I was talking about, that after the end of the iteration, it is like the counts are not very accurate. They are just a way of counting the things, that if the particular candidate, which elements are present for most number of times, that can be calculated, and ultimately that element will be staying in this candidate 1 and candidate 2, but their count will be manipulated because we are subtracting both the things even if there is one mismatch. So after we pick out these 2 elements, we should run through this array, particular array, and check the count of the number of time 1 is present and the number of time this 4 is present. If they are present for more than n by 3 times, which is 4 in this case, if they are present 4 times, then only we add it to our answer. I hope this is making sense. Obviously the intuition wise this is very hard to form on your own, but let me tell you one more conclusion over here, that this approach over here, this is involving some space, but this is being faster, because over here I need to travel the array twice, because once to fill out the values of candidate 1 and candidate 2, we will get 2 elements that are present in candidate 1 and candidate 2. Then we need to run again and check for the counts. So this approach that I discussed earlier, the hash map approach, that is faster, but obviously that will take order of n space complexity. Over here also I cannot really say that the first approach is faster, because this takes 2n, which is nothing but order of n only, right? The previous approach was also order of n time complexity. This is also order of n time complexity, but this is basically order of 2n time complexity, because we are iterating twice. That's the only difference. Cool guys, I hope the thing is clear.